guys, this is Stoichiometry 104, and this is just a wrap up and some examples for you to assist with the stoichiometry assessment. So we want to remember that stoichiometry is just is using the amount of one substance to predict the amount of another. So if you have the amount of a reactant, then you could predict the amount of another reactant or the amount of another product, but it's always done in the same manner. It's always done in a moles to moles at its base calculation. So you're always going to have the moles that you know about or that you're given, and you're going to translate that into the moles that you don't know. Okay, and the way that you do that is to use a mole ratio. And the mole ratio is just the coefficients from the balanced chemical equation of the unknown substance over the known substance. Okay, all right, now there's a couple of different options for getting to the moles known. You can be given the moles known, or you could also be given grams of that substance. And if you're given grams, then you just have to translate into moles. So you do 1 mole of whatever that substance is over the molar mass on the bottom. So it's essentially just dividing by the molar mass. And then if you're asked to answer in grams, then you would multiply by 1 mole on the bottom and the molar mass on top, and that would be of the unknown substance. Okay, and the other way that you could be given information would be liters of gas at standard temperature and pressure. And we want to remember that the equivalence for that is that 1 mole of any gas at STP has a volume of 22.4 liters. And if we're asked to answer in liters of gas at STP, then we would multiply by 1 mole of the substance on the bottom and the 22.4 liters on the top. Okay, so that is the I call the stoichiometry map. Okay, and what you want to remember besides all this information is that if we split this in half, this is the question and this is the answer. So at its heart, a stoichiometry calculation has to be at least a moles to moles calculation. But if you're going from grams to grams, then you would add those in. If you're going from grams to moles, you do this. If you're going from moles to grams, do that. And you can add in your liters of gas at STP. Okay, a couple of the things you want to remember is percent yield. ELD, I think I spelled that right. And that is the actual yield over the expected, or the theoretical, that's another word for that, times 100. And we know that the theoretical is the answer to a stoichiometry problem. Okay, and you can rearrange this. You can rearrange this to get the actual, and that's going to be equal to the percent times the expected divided by 100. So that's just a little bit of baby algebra here. Okay, and then the last thing that we also talked about, so this is the stoichiometry map up here. That would be my first point. Second point is percent yield. And third point is the limiting reactant, excess reactant idea. And the limiting reactant, remember, is the substance that runs out first and therefore limits the amount of product that can be made. The excess reactant is the substance that's left over. Okay, and in order to find the limiting reactant, excess reactant, do a have a need calculation. And that slash is not a division sign, it's just like a do a have and need calculation. And that was in Stoichiometry 103, part 1 notes. Okay, so this is part 1, and I'm going to come back with part 2 and do a couple of examples. I'll do just a regular stoichiometry calculation, then we'll throw in a percent yield and also a limiting reactant, excess reactant. Okay, sorry if you hear background noise. I'm at the University of Washington waiting for Eric to be finished with his MRI. So that's what's going on. All right, thanks guys.